We're all almost done getting the flu. We'll all be here the rest of our lives now. All right. Okay. What were we talking about the last time I taught you? Polynomials. Last time I taught you, we did talk about polynomials. What did we do with polynomials?
Multiply.
We multiplied, we simplified.
And we added them and subtracted them.
Added them and subtracted them. Okay. I think I don't like how this unit starts because it's like weird. We're used to multiplying them. What we're going to talk about today is we're going to talk about factoring something. So, anyone off the top of their head remember the thought of factoring? Factoring?
No,
I remember. You want a hint?
Yeah.
What? What'd you say? Fractions.
I told him. No, you didn't. Yes, I did.
Hold the phone. All right, what if I gave you the fraction 20/30? That's like 2/3 or it is 2/3?
It is. No.
Is it like simplifying the...
Okay, so what did you do?
You simplified it.
We simplified it by what?
10.
By 10. Okay, how did we know that both numbers were divisible by 10? Did you have that 0? Could I have done, remember these things?
Oh yeah.
That looks disgusting.
I kind of remember it.
I did not like annoying For funsies, what are my factors of 30?
10, 30.
I love that we're going in order, yes.
3.
What am I?
6 and 5. 5 and 6.
6 and 5.
Okay. This is what I call factoring. I am finding what two numbers I can divide out of both of them to simplify it down. So it is simplifying, but there's a practice. So what's the greatest common factor?
10.
Yeah.
Do they have any other factors in common?
No.
Yes,
Yeah.
they do.
2 and 1.
5.
Oh,
1.
not 1.
2.
Okay, so they have 3 factors. Typically we choose the what? The greatest common? Whoa. So the greatest common factor here was 10, and we simplified it down, correct? Oh my gosh. Is this equivalent to that?
Yeah.
Are they equal parts?
Yeah.
All right, if I eat 20/30ths of a pie, and Emmy eats 2/3 of a pie, did anyone win the contest? We ate the exact same.
Yeah.
All right, Marty liking this lesson better than first. Good news. So, I mean, they had 4 comments, y'all had 3. So if we're choosing who's better. You don't even know what I'm talking about. And I've already talked about what I'm talking about.
Wait, 4 points.
I'm going to do this with you. Don't do anything with it, okay?
Wait, I don't understand this.
I know. It shows.
You can't have
4 points.
the comments on the okay?
Oh. No, it's 4 and 4. You just didn't see that early.
Y'all are awkwardly situated. Alright. So, on number 1, I need a paper. We got 16x squared plus 64x minus 8. Alright, what we're doing today, that's a what?
Polynomial.
It's a polynomial. More specifically,
Trinomial.
it's a trinomial. Okay? Now, what we've done up to this point is we took 2 binomials, multiplied them to get a trinomial, yes? We multiplied 2 things, got all the pieces, made it a polynomial. We got that as an answer. What we're doing this week is we're breaking it apart. Okay? We're factoring it. So what I want to look at is what number, so essentially I need my little T-charts. While you wait in suspense, think of what factor all of those could divide out by. Yes, sir. My favorite algebra teacher is delightful, and we're learning how to factor trinomials. Would you like to step in? Mr. Miller will be right over for this lesson.
Oh, that's great.
Yes, she is.
Yucky. Why are you wearing your dress like that? It is not a scarf.
Mm-hmm.
You are not a scarf. It is not.
Macy, have you seen Mr. Miller's email back to you?
No.
Go look right now. Yeah, it's charging because we're not on Chromebooks right now.
Do I need to look at it? So check your phone.
I will pass the massage along message. Thank you, guys. Make sure you get that reading worksheet done before his class because you'll only be in there for a snippet of time.
Oh yeah.
So that's what you wanted. Alright, so I could make T-charts for these numbers, but they're pretty compatible numbers in our brain, right?
They have 8 in common.
They all have 8. So if I said 2 times 8, 8 times 8, 1 times 8, correct?
Yeah.
Are there any other factors? 4. There's a 4, so 4 times 4, 4 and 16.
And then 4 and 2.
4 and 2?
And then 2.
1.
And then 2?
Yeah.
1.
So that was just a quick factor. Now I want to find what's the greatest common factor between all of them.
8.
8 and all 3?
Yeah.
Alrighty. So what I want to do is I'm going to put a factor of 8 out to the side. And now I'm going to factor 8 out of each term. Okay? What's 16 divided by 8?
2.
And then this x squared is going to hang along for the ride because I don't have that variable with me.
Wait, when you write these down,
I would.
Okay.
That's just me. I'll let you catch up with me. Just stare at me when you're ready.
I can't do this for long.
I can. I will blink, but I can stare for an awkward amount of time. Alright, now, what's 64x divided by 8? 8x? 8. What's negative 8 divided by 8?
1.
Alright, put your pencil down and have that written. Would you say this expression and that expression are equivalent? So you're telling me we could multiply that out. So 8 times 2x squared is what? 16 x squared? What about 8 times 8x?
Yeah.
What about 8 times negative 1?
So it's kind of like you're just turning it into like if you're distributing it.
I'm simplifying it back down.
Yeah.
Last time when we multiplied binomials, we multiplied them together to get that long polynomial strand. This time we're looking and we're simplifying things out. We're factoring it out, okay? So if I were to look at the next one,
My goodness, I wrote this all.
just draw little arrows.
Oh, fine.
The next one Alright, what are the two coefficients that I want to factor? 32 and 24. Okay, off the top of your little headsy head, what can you think?
4.
8 and 4? We got 4 and 6, 4 and 8.
That's 3 and 8.
Oh, yeah.
Wait.
I was not calibrated.
Yeah.
Alright, is that correct?
Yeah.
Okay. Are there any others? 2?
2 and 12.
Why is 1 not?
greatest common factor?
8.
8? Alright, so when I'm factoring these numbers out, I can factor 8.
Wait, where did you get 8 from?
Okay, so the greatest common factor between 32 and 24 was 8. 3 times 8 and then 4 times 8. So I know I can divide 32 by 8. Do you agree? And I can divide 24 by 8. Do you agree?
Yeah.
Oh, I owe Lila 2 Jolly Ranchers. What else? I can divide something else out.
1.
I could 1, but 8 is the greatest common factor, and that's the factor I'm sticking with. What else can I divide out of each
12?
term?
What can you do?
Number. The X.
The X. Oh, 2 Jolly Ranchers. Okay, so what would the expanded form of x squared look like?
X times.
Okay, what would the expanded form of x look like? How many x's can I factor out of both terms?
1.
How many does each term have to give?
1.
They both have 1, right? Yeah. Okay, so that means I can factor out an 8x of that one. And I can factor out an 8x of that one. They both have an x that I can divide out. I know. Okay, put your pencils down for this one. Follow along with me. Can I put a 1 right there?
Yeah.
Okay, so if I were to factor this out, if I were to divide that greatest common factor, 32 divided by 8 gives me what? 4. Okay. Now, if I am dividing exponents, what's the basis of division? Subtraction. Okay, I'm going to ask that again. What's the basis of division? Okay, so what am I doing with my exponents if I'm dividing them? Subtracting. So x squared minus x1. Okay, because x squared divided by x is x1. Now what about negative 24 divided by 8? Negative 3. Now if I'm dividing x1 divided by x1, division is subtraction. So 1 minus 1 is 0. I don't put anything. Now wait, Amy. For funsies, if I were to work it back, 8 times 4 is what? Now I'm multiplying, so I do what?
You gotta add their
I gotta add them. So x and x gives me
x squared.
Okay, 8 times negative 3.
Negative 24. X.
And then if I don't have a variable, this one just hangs along. Now you can write it down. We have worked to get an answer, and now we're essentially working to take apart the answer. We gotta pivot in our brain. Alright, with your partner, I want you to attempt 3, 4, 5. I'm going to give you about 10 minutes, and we're going to come back together. 3, 4, 5.
Wait, so on those ones, like, do you only do that when you have a thing like polynomials?
Well, if they have an x in each term, then I can take it. So like this one has an x in each term.
Make a chart, I guess.
Yeah. Does it have an x in each term? Okay, got it.
So we make a chart.
Okay.
Let's make a chart with ice.
Wait,
4 and 10.
So you can take out an x if each term has an x.
So are we doing the X on the outside of the parentheses?
If each term has an x, then you can take out an x.
Oh, shoot. I did it wrong then. Yeah. But I think it's different. Yeah. We can't make it. There's not.
Here's your outside number.
Avery's use the restroom now. This is.
We don't have to right away. No. We're gonna do factor it out. So then it'll be like the last one. Because if you're gonna do like two terms, oh no, yeah, but like we have to also do these terms. So showing my options. You just do two. Yeah. So you have to do like.
What did you factor out?
Oh, and then you have to do one. So two for the
Because if I were to resolve it,
No, it's one time because so there's prime numbers and non-prime numbers and prime numbers. Okay.
would you believe? If it's beautiful binder and it's almost missing the one next page I needed, but this binder, the one next page I needed, found it in 2 seconds. But then this one's 4.5 and so remember 5, 6.
So what did it before?
I put the 4 out there. That's the 4. Sorry, that's my bad. Oh, and this one. That's the 6.
You know, Amy, you should really move your bed practice. Really? Because I'm looking like not looking down.
Yes. Yeah.
4 and 9. Shut your mouth. You're getting on my nerves. And then so 36.
Oh, sorry.
I'm
Alright, I'm gonna pull you back together really quick. Alright, put your pencils down. Let's go over this. This is just your notes page, so fix it if it's not correct. Otherwise, I don't know. Alright, so I want to find what number can factor out of each coefficient. So between 4, 10, and 2, what number can be divided out of each of them?
2.
2? Okay. Can I factor an x out of each term?
No.
Why not?
Because they're not x.
So, for me to factor out an x, each term needs to have an x, and which term is missing an x? Okay, so all I can factor out is a 2. So now, I'm going to divide. 4 by 2 is 2. And if I don't have a variable to divide, this one just hangs along for the ride. Did you get that far? Okay. What about 10 divided by 2?
5.
And if I don't have a variable, it hangs. Negative 2 divided by 2?
Negative.
How do we feel about that one?
Yeah.
Makes sense? Yeah. Okay. What about this one? I'm trying to find a common factor between 8, 20, and negative 4. Which one? 4? Can I divide out an x? Can I divide out a variable?
No.
Why not?
Because the negative 4 doesn't have an x.
They don't all have one. So 8 squared divided by 4 is? Okay. 20x divided by 4 is? And then negative 4 divided by 4. We good with that one?
Yep.
Okay. Alright, so what's my greatest common number between 36 and 16? 4. Can I factor out an x?
Yeah.
Why?
Because there's an x in both terms.
Okay, if I have an x in both terms, that means I can divide out an x from each. So, I'm actually going to divide out 4x from each one. Yes? So now, when I do this, 36 divided by 4 is? 9. Okay. If I'm dividing exponents, what do I do with them? Subtract. So, x squared minus x1 is? Okay. 16 divided by 4? And then x1 divided by x1 is 1 minus 1 is? 0. So I don't put anything, correct?
Yeah.
Now, if I were to work this, is there a way to check myself?
Yeah.
9 times 4 is?
36.
And then multiplying gives me x squared. 4 times 4 is?
16.
Did I check myself correctly? Alright, now let's look at our notes page for the day. I wanted to even exclude so this white paper will just go behind your blue paper when we go to clean up. I'm losing track of what colors I've used, so if you have a suggestion, let me know.
You should do.
Do we have an orange one? I don't think we have burgundy.
We don't have orange paper.
I don't think we have.
Oh no, we've done it on orange paper.
We have lost your.
Any blue? We don't have any blue?
We have 2 blues. We have
I have no blue.
you should have blue. We have
What's blue? Systems of equations?
That's great.
We should do gray.
This one with the here.
This one.
I can't get it.
Ah.
I don't know why I don't have that one. What the heck?
Pitch red.
What
Red.
other colors exist?
I think last year my 4th grade would pick colors, and one time they said, let's do black, and I said, okay.
Oh.
Obviously nothing would show up.
Then we should get white. We should do gray.
Crayons.
Gray?
The day
What
you
other? Ooh, you should do like magenta.
that was peak childhood.
Or teal. It's
The
so
day you get the crayons split. Y'all so sad whenever those lights turn. Never even got used.
All right.
The person who's watching this, that's the
I don't know, they'll probably reach out to you and agree with the day that. All right, so factoring. What have we discussed factoring is?
The greatest common factor.
Greatest common factor.
It's the one which both of them have the greatest common.
You can't use the word in its own definition. Factoring is factoring.
Yeah.
Okay,
Well,
but what
it
do we
is.
do?
We find the greatest multiplicative thing. Like you did the factors of the.
So you find the multiple of both numbers, and
Yes.
what?
And then you find which ones they have in similar. The highest
You're right, I should just
similarity of.
Then we found the highest similar one, and then we divided. So factoring is essentially the process of simplifying through division. Okay? So I said that. Process of simplifying through division. Process of simplifying through division. That's what we're doing, yes? What?
Oh, I figured it out. I was missing an I.
Okay. Alrighty. I'm going to scroll up and zoom. My shoes are squeaking. Pause for dramatic effect. Oh my gosh. Oh, I'm using the mouse. Alright, what do you notice about these two terms in relation to what we've been doing?
They both have an x and a y.
They both have an x and a y, they're weird.
Yeah,
But the exponents of the x and the y are not the same.
Exponents are not the same. Alright, so they look a little funkier, would you agree?
Yes.
Okay. We're gonna follow the same process. What was the first thing that we did when we were simplifying?
I found the greatest common factor.
Okay, so let's find the greatest common factor. We're gonna look at 12 and 20. We got 1 and 12, 2 and 6, and I'm so glad Elijah said 3 and 4.
It's like you're putting words in my mouth.
I know. What about 20?
4 and 5.
There's another 4.
4 and 5.
The important ones to get that.
But how do you know it's the important one unless you do all of them?
Because they have 4.
Because it's 4.
But there's also 2 common.
What's the greatest common factor? 4? So we got 2 and 4. But, so down here you have the words GCF, right? Yeah.
Yes.
I'm going to write it.
Wait, what is the least common factor? Thank you.
We're going to turn this and into a multiplication sign, because that's going to make our life easier.
That's a plus.
Yeah, we're going to turn the and into a plus sign. Basically the same thing.
12x.
Alright, so I'm dividing out a 4 out of both of them. Do we agree?
Yeah.
Is that different than the process we were doing before?
No.
No, I found the greatest common factor. I wrote it below the number, yes? Alright, now, here's where we have fun. Looking at my x's and looking at my, so I have x to the 4th and x cubed.
Yeah.
What does x to the 4th look like expanding?
X times
X
x times x times.
Wait, no. X times x.
Do you agree with that?
Yeah.
X to the 4th would be x times x times x times x. What about x to the 3rd?
Y. Oh wait, so x times x times x.
So, how many x's can I pull out of each term? 3. They share 3, so I can take 3. 1. So within my greatest common factor, I can factor x to the 3rd out of both terms. They have both of that to give. Are you following me?
Yeah.
A little bit? Okay. What about y? What would y look like expanded? What would y8 look like?
Y times 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 y.
A lot more y's than
They're answering my question, Gilbert.
Yeah, Gilbert.
Berto. Said y and 1.
I do not feel like writing that is a lot.
But you will, because your notes need to be just so accurate. Yeah.
So many y's.
I'm so committed to your teaching, Miss Griggs. We all write down all 8 of those y's.
Why? I'm pretty sure I only wrote
1, 2, 3.
A better teacher would have adapted these notes since last year, but you're stuck with me.
7.
Alright, how many y's can I factor out of both terms?
Only 1.
2.
Only 1.
Because whenever it looks like 0 pairing in that,
I misaligned some. Alright, so with our GCF, our greatest common factor that we can factor out, that we can divide each term with, is 4 x cubed y. Do you agree?
Yeah.
Get it together, Kaylee. So now, I'm going to erase this to rewrite it. She's messing up my video lesson, really.
I practiced theory.
Alright, so now let's factor it out. Let's actually factor. I'm going to take my greatest common factor and divide the terms. What's 12 divided by 4? 3?
And then
Okay, pause. I'm going to make sure everyone's with me. Okay, so if I'm dividing right now, what's the basis of division? So what am I doing with my exponents? Okay, so x4 minus x3? x1?
yeah.
And then y1 minus y1?
There's
No Y.
I don't put anything.
no more Y.
So that term is simplified, yes?
Yes.
Hold your breath like 15 seconds.
Now, we're going to divide this term by this term. 20 divided by 4.
5.
Okay, now I'm dividing exponents. What's the basis of division with exponents? Subtract. So, 3 minus 3?
0.
Do I put it?
No.
No. Y8 minus Y1?
7.
Booyah. So now, if I distributed this, would it equal back up to that? Yes.
That's so tricky.
But I bet you're out of room, so I won't.
I am. There's too many Y's in my way.
Why?
Why'd you write them so big?
I didn't. Should've.
Alright, let's look at this one.
7.
So, we're going to start with doing
14.
what?
14. 14. Yeah, 14. It's 14.
We're going to start. Yeah, that's step 1. Writing them in the things, Elijah.
I'm trying to high five him.
Hi, Gilbert doesn't want your high five.
He already did. He likes it.
Yeah, I made him Germex. You don't know when he was not Germexing. Alright, so we got 1 and 14,
I just saw his face.
2 and 7.
Oh, shoot.
Oh, we're on a new one.
I noticed that. I just didn't run first one. But yeah, there you go.
This is a learning lesson. You guys
You know what's also a learning lesson? Me teaching right now.
Bum, bum, bum.
I know, you would applaud if you were paying attention because it's a good one.
I know.
What's the next step?
We find our greatest common.
Not 4 and
Which is 14.
4 and 7.
4 and 7.
Wait, I spelled that right? I knew it, guys. I knew it.
You were on my number since Lily.
Oh, I spelled it both ways.
Alright, so what's the greatest common factor that can be divided out of both?
14.
14.
I said it a second ago.
What?
Alright, so now I can divide 14 out of both. Now I want to look at my variables, yes? Okay. Scadio. What's m to the 10 going to look like?
Oh my goodness.
M times 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 M.
And we're all going to write out those m's because we're committed to having strong notes and we're committed to the learning process.
Let's write 10.
And on one of those times where you ask me a question on a test and I kind of point at something on your notes page and you don't have it,
Oh shoot.
I can't help you because I say,
That looks so silly. Just like.
it does look
It's
so
a
silly when you
line.
don't have anything written down. And
I have it written down. I am dedicated.
Alright, what would m to the 1 look like? How many m's can I factor out of both?
1.
Just 1. So in my greatest common factor, I'm going to have 14 m. What about the n's?
N, 8. So N times 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 N. It's weird. Like you're doing the N and then you gotta say the N. I love that. 1, 2, 3, 4.
Okay. Do they both share an n that I could factor out?
No.
So will there be an n variable in my greatest common factor? No. Alright, so now let's take that greatest common factor and we're going to divide those terms. You with me? 14 divided by 14.
1.
Now you're interrupting my video lesson.
No way. Can't focus.
Gilbert can't focus.
Gilbert can focus.
What's the basis of division?
Subtraction.
Okay, so 10 minus 1 is?
9.
Get away from my drinks while you sneeze.
I'm not sneezing. I'm blowing my nose.
Still.
It's not the same thing.
Get away from me. Alright. 28 divided by 14.
Really mean. I don't know.
2?
Yeah.
Y'all agree with Emmy?
Yeah. Y'all should all agree with me.
No.
N1 minus M1?
0.
0, do I show it?
No.
Yeah.
Okay.
So that's not it.
What about in 8? What happens to that?
It just stays
It just stays.
Wowza. I know you can check that if you wanted to.
I could check it if I wanted to. For funsies, let's do it. Amy, I saw that eye roll and it just stung me to the heart.
I nodded.
It just stung. 14 times 1.
14.
Okay, now that we're multiplying, what do I do with my
Add
exponents?
exponents.
I add my exponents.
So
M10
plus.
hold the phone, Emmy. So now I got that term done, yes?
Yeah.
Now I want to say 14 times 2 to give me. Okay, I don't have either of the same bases, so they're just going to hang along. M1 and 8. Did I round back out to what I started with? So factoring, we're just breaking it down. We're simplifying things out.
Yeah.
It's like 3 minutes. That's so much learning. Whatever, you can back up. Put the white page behind the blue page. Yes.
My knees are so broken. Oh, why is